All right, so here's lesson 17 coming your way, problems 1 through 48. And we'll talk about how we're going to grade in class, and 70 problems on this test, 70 minutes. Some folks are having some serious time trouble. Other folks are just finishing what they can in the 70 minutes. We'll probably start taking off whatever you get right out of the first 20 or 30 problems. We'll take a significant number of those out at this point. Hopefully you've overlearned those, which means you'll be able to take it into your next class and you won't forget how to write the equation of a line, which nobody seemed to remember from Algebra 1. So that's what we're battling, and I think we can make some gains in that area. So let's have at it. 5, -8, write the equation of a line through these 2 points. So most everybody's immediately doing that. Occasional sign error, 5 to 12. I'm not seeing a sign error there, but -8 to -16. I am seeing -8 to -16 with people going in the wrong direction on the number line. To get from here to here, you got to go back 8 units. And so that was our answer to problem number 1. And I have an eraser, so let's get rid of that. All right, the sole purpose for problem number 2 is to make sure people aren't coming in with grade level problems, adding and subtracting fractions and multiplying and dividing. And, national testing suggests that we're well behind grade level and need to practice this, and we still do. So let's practice it. No one's having problems saying -2/3 x, and I'm not having a problem with anybody having a problem with that. That's good. -2 times -7 is positive 14 over 3. And we are still having some trouble with subtracting 8. Having a little bit of trouble with I don't think we're having trouble writing 24 over 3. That's -8. But yeah, some sign errors here. So 14 minus 24 is -10, not positive. -10/3. Okay, so that problem will probably still be on there for most folks on the next test or 2 tests from now. So clean up your fraction work if you're getting that wrong. 3 coordinates. Well, that's nice. I just erased the problem. I don't think we're having trouble with, I'll make up a new one. Y - 2 equals 5/7 x plus 1. Okay. Little trick of the trade. Stay in one column, -1, change it by 7, go up 7, boom. Then work with the other column, 2, that's what makes 0 equals 0, point slope form, and go up by 5, 7, 12. Okay, most people have that right now. Occasional sign error. 2 coordinates for 53x minus 37y equals 1. I'm hoping we really make some gains here, because the skills that come from this problem, this single problem, are going to allow us to do 2x squared minus 12x plus 3y squared minus 6y equals 17. Now, it's probably not a friendly problem right now because I didn't check to make sure the numbers were user-friendly. But we're eventually trying to get to situations where we can graph ellipses. The ability to do this problem hinges on the ability to do this one. And I'm not seeing what I want to see. I am not seeing, we started with 2x plus 3y equals 12, and I wanted to see 0, 0 in a table. That's what I wanted to see. All right, and the fact that I'm not seeing it suggests that some folks aren't looking at any of these videos or really looking at the answer keys to the tests. Got to be honest here. All right. 0 means that goes with a 4. 0 means that goes with a 6. And you immediately have graphing knowledge. Same thing in this problem. We can't get there till we get here. So what were the numbers that I was looking for? 0 goes with -1 over 37. And 0 goes with 1 over 53. I hope you're watching this video, because I'm ready to grade that problem at midterm, and I'm getting ready to write some progress reports. All right. Solving. Minus 5x over 3 minus 9 equals minus 5x over 2. The problems are division by 2 and 3. We get rid of them with a multiplication by 6. And I get minus 10x minus 54 equals minus 15x. And I usually have another number there, but I'm trying to shorten the test. And this is the skill that I'm looking for. So that shortened it up a little bit. I'm going to bring that to this side, which makes it 5x. I'm going to bring minus 54. And I hope I see lots of those answers. And I am. We're making good gains on that one. All right, those are the 5 problems out of the way. I didn't bring Renee. Renee, how come you're not here? All right, I'm going to get Renee the card. Just give me a moment. Can't remake this video. I do not have time. Either now or never. All right, I think getting Renee saved me having to move the tables like this. All right, Renee, there we go. All right, let's park you where you belong. Right here, next to this desk. Back here, I missed one doing this one time. I missed a whole block of questions one time. There we go. System of equations. It's easiest to do elimination. So we got 3x minus 2y equals 4. I'm going to double everything in this line. Oh, I'm actually going to multiply by negative 2. Everything in that line. So that gets me minus 4x. I make a lot of mistakes with this because I do it too quickly. And minus 2 times 3r. I was careful. That means the column, y column cancels. I can see minus x equals minus 2. And I'm very happy because that answer is 2. And a nice answer like that means I can plug it back into either one of the equations. I'll plug 2 into the top equation. 6 minus 4. I'm sorry. I'm plugging in 2 for x. 6 minus 2y equals 4. So minus 2y equals negative 2. Looks like y is 1. So it looks like the answer was 2, 1, and I'll plug it into the bottom equation to see if it works. 4 minus 1 is 3. I don't have to ask the teacher if that's right. I checked it. It works. Well, that was 2, 1. No, I should have been putting the answers over on the side for people to, I'll do that as we go along here. So this is another one. This question was just to teach functional notation. So a lot of folks didn't know that this is what it meant. And now you do. That's good. That's learning. Now, can we do the calculation? A minus times a minus is a plus. I got 4 3s, 12, and I'm going to divide by 7. And I'm going to subtract 5. So I have 12 sevenths minus 35 sevenths. That's the opposite of 35 minus 12 in the numerator. 35 minus 12 looks to be 23, so it's minus 23 over 7. So a lot of sign errors there. Try to clean them up. Okay, so that's that one. Guess I'll just keep going it this way. So f of x, there's another name for f of x. It's minus 4x minus 5. So I'm going to set that to 3/4. F of x equals 3/4. That's f of x, that calculation. I'm setting it to 3/4. Now I can erase this and just get an answer. So I'm going to multiply by 4. I'll do it going north. Minus 16x multiplied by 4. Minus 20. If I multiply this by 4, I hope everybody can see that cancels. And therefore, I'm going to bring the 16x to the other side. I don't like dividing by negatives. And I'll make this minus 23. And now I can see minus 23 over 16 is the answer. That takes care of this one. F of x, g of x. And I think I asked f of 3. And that threw some people. I hope it doesn't ever throw you again, because I think f of 3 means I'm plugging in 3 for x, and I don't get 3/4. F of 3 is 21 plus 4, 25. So another name for f of 3 is the number 25. And now I want to do f of 25. Well, that's f of 3. Why don't I make it f of 25? I'm not going to get the same answer anymore. 7/4 is $1.75 plus 4 is 179. Saw some really strange answers for that one. Not sure why. All right, so that's 179. All right, this is pure effort on your part. This is just mechanics, showing the diagrams as to why this works. That's another matter. All right, taking a cube away from the inside of a cube. Oh, it's geometrically, it's a conundrum. All right, so we started with 27 minus 8. We also did 27 plus 8. We said you can work with the cube roots, and we drew the cubes. 3 minus 2, then this one is 3 plus 2. That's the start. The finish, I don't care about that anymore. I don't care about that anymore. I'm working with these numbers. And I know I got to cube the first, square the first, and I got to square the second. I know I got to square the first and square the second. Challenge is to learn how to do the middle term. And the middle term is this product. 3 times -2 is -6, changing that sign. 3 times 2 is 6, and changing that sign. Those products will give me 27 minus 8 on the left and 27 plus 8 on the right. So what happens when we increase the level of difficulty slightly? That's what happens. Level of difficulty increases slightly. Nothing else changes. I'm still working with the cube roots, and it's a minus. So that's 5x, and that's 3y. Everything else comes from these two numbers. I have to square that. I have to square that. And I have to change the sign and multiply. So as far as I'm concerned, that falls into the category of, are you looking at it, thinking about it, and practicing it? Okay, and I think with 2 weeks to go till midterm, there isn't anyone in the class who can't do that. So therefore, go do it. All right. Is it helpful to, well, I'm going to keep doing it the way we're doing here. So the range of a cosine function. Cosine measures width in the unit circle. So we have a hypotenuse of 1. How far is it to the right from 0? How far is it to the left? And I hope you say it's 1 unit to the right and it's 1 unit to the left. As we draw triangles, that x value is positive, that x value is negative, because we're in a coordinate system. Okay, so what is the range of the cosine function? The cosine function goes from +1 to -1, +1 to negative, +1 to negative, so on and so forth. So what am I doing to this range? Oh, I'm multiplying it by 15. Oh, so my hypotenuse now is 15. The unit circle just got 15 times bigger. Then I think I'm going to the right 15 and to the left 15. Oh, and if I'm adding 7, then I think I'm adding 7 to 15, and I'm adding 7 to -15. And so what's my range? My y values are between 22, less than or equal to 22, and also bigger than 7 minus 15, -8. Yeah. So all of a sudden I wrote something like this. We're trying to make some gains. Y equals 3 sine of, I don't care what's complicated here. This is all about an angle. I can make it as complicated as possible, plus 7. Then my midline is 7. I'm going up 3. I'm going down 3. And my range is from 4 to 10. That's the range of that function. Okay, hope you're watching this. Hope you get it right the next time. Minus 2x squared. I'm going to do this by erasing as I go. Minus 2x squared times 3x is minus 6x cubed. I have done that. Now, I could go over here and look at this and go, well, I have an x cubed right here. Now, I've done that. Minus times a minus is a positive 14x squared. Let's see if I have any x squareds over here. Oh, I have a minus 2x squared. I've seen cancellation of the 2x squareds, but I have a minus sign. So this is minus 5. Ah, I see a minus 4x. That's positive 4x. So maybe I move this over a little bit in my mind's eye. And I've done that. I've done this. I think I have a minus 1 here. Well, let's add it up. Let's see. Minus times oh, lordy, minus 11x cubed plus 12x squared. I only have the 4x in that column, and it looks like it's minus 6 if I add those columns up. Suggestion, speed up your work the next time. Organize it that way. You move along a little faster. That's that one's done. All right, so I'm hoping you can get to the point where you see minus 6 coming out of this. I hope you get to the point where you see positive 1 coming out of that. I hope you get to the point where you square these and add them up and you get 37. And if you take away 12 away, you're at 25. And therefore, you know your radius is 5. Now I'll do the problem out. Completing the square. X plus 6 squared minus 36. Plus, guess I got to erase this. Plus y minus 1 squared minus 1 equals negative 12. I have x plus 6 squared plus y minus 1 squared equals 25. And I hope you can see negative 6, 1, radius of 5. We've certainly drawn the Pythagorean relationships enough. We talked about it in class. Mechanically, a little more practice. Hope you get there. E to the x plus 2. Well, I know that e to the 1.1 plus 2 is approximately 5. E to the 1.1 is approximately 3 plus 2 is approximately 5. So I started with 1.1 for x, and I got a y of 5. An answer of 5. I better get a calculation where if I start with 5, I come back to approximately 1.1. Well, let's see how we do it. E to the x. Right, so the first thing you do is you change. I'm not skipping any steps here. You switch your x's and your y's, and now we solve this equation for y equals. I think the first thing I have to do is subtract 2. Well, that's a new number. Let's let n equal x minus 2. Some number. What am I going to do to undo e to the y? Well, that's the ln. So I have to do the ln of this number. And that number has 2 parts. So a big time algebra 1 skill. Putting it in parentheses. Huge skill in algebra 1 is being able to visualize that and understand why I'm putting parentheses around it. To get there, it would have been nice to plug a number in to see if it works. Let's let x equal 5. 5 minus 2 is 3. And the ln of 3 is approximately 1.1. It's one of our memorizations. And then you move on. If you didn't do that step, then a lot of you made the mistake, the algebra 1 mistake, of saying the ln of x minus 2. So that's a big time pause. Big time pause as in this is coming your way forever as you move up the ladder in this discipline. So that's a gap. That's not a gap. Let's go here, not the other place. Okay. So here I asked you if I gave you the inverse of this. What's the same question? All right, we're just working with this calculation. So same problem here, exactly the same problem. Subtraction of x, subtraction of 7 becomes addition of 7, and then multiplication by 5. Here's your number, there's your new number. X plus 7 is your new number. You got to multiply it by 5. You need a parentheses. And if you had thrown in a number like 10 on this side, You would have immediately, well, let's get something bigger. What do we want? So we get a positive answer here. How about 40? Let's throw 40 in there and it comes out as a 1. Over here, a 1 better come out as a 40. I think 8 times 5. I think we're okay. Let's move on. So, same mistake here as the previous problem. Got to correct it. 6x squared plus 12x minus 7. We're just looking for the vertex. You have to correctly do minus b over 2a, which is minus 12 over 12. 2 times 6. Well, I'm seeing -1. Now we have to figure out what y value goes with that x value. Oh, I think we have a calculation that can help us find y values if we know the x value, which we now do know. So we do it carefully. -1 squared is 1 times 6 is 6. Minus 12, we are feeling good. There's the 2 to 1 opposite, -7. When you put those together, you always get half the middle term. And -6 minus 7 is -13. And most people are getting that right. It's a good thing. Okay, so we got x minus 4 on the x side of things. We put in a 10, we get 6. Well, if you're doing that, you're thinking linearly. That's to the first power. We're not doing the first power. We're doing the second power. So it's nice if you write it there. And when you put 10 in, I don't see 6 coming out of this. This is where things are changing. This is where numbers, they go in and they change. Yeah, pull the curtain. And if I drop a 10 in there, I think I've changed by 36 units. And maybe I don't want to change by 36 units because I'm trying to get from 7. I'm trying to get from 7 to 12. That's 5 units of change, not 36. And that's how that works. All right. X squared equals -5. I told you the story. I used to sneak up behind people if they forgot the plus minus and go, ah! Scare the class. And pretty soon everybody was watching me sneak up behind somebody and said, write plus minus. And we made a lot of gains. I can't do it anymore because we have these concussion protocols. Got to be careful. Right? But the first thing I'm looking for is this. That's the first thing I look for. I'm not seeing it much. Next thing I'm looking for is that. And it's nice if this is in here, right? That gets you half a point. Moving the minus sign out, saying, well, wait a minute, you got imaginary answers, gets you the other half a point, and then you get one of those from me. And if you miss this and you miss that, nothing, nada. I'm learning Spanish. This problem's driving me nuts. So let's look at 5x squared equals 7x. And let's look at it geometrically. Let's look at x and 5x, 5 times that length. And over here I have x times 7. I mean, if this is area, this measures area, well, it's got equal area. So I think I can draw it that way. Now, what are your solutions to this? You plug some numbers in. Let's try 1. 1 times 5 is 5. 1 times 7 is 7. You know what? It's not equal to 1. What I'm hoping you see is, what if x equals 0? Okay, so this is 0. This is 0. And this is 0. Well, I think this is 0, and I think that's 0. So I immediately have an answer. What else works? Well, if these are the same, then these have to be the same. 5x has to equal 7. It's got to equal 7. So x has to equal, if 5x has to equal 7, then x has to equal 7/5. And I guess I have 2 answers. Now, we're not going to draw these out forever. So what do? we set quadratics to 0 because if you have 0 equals 0, you got to have something that's staring you in the face. So we make this thing equal 0, and we take out what's staring us in the face. What's staring us in the face is x. It's common. It's common dimension. And 5x minus 7 is writing it as a product. And we have answers of 0 and answers of 7/5. And I'll let you look at that long enough to make sure you see why. I can only tell you what it is, not what it isn't. 5i to the 37. I don't do the textbook. I equals square root of -1. I squared equals -1. I cubed equals the opposite of that. Positive I squared negative I, excuse me. So tell I don't do this. I to the 4th equals 1. I mean, there's a pattern here. All right, there's a pattern where the even I situations either equal +1 or -1, and the odd either equal positive I or negative I, right? I don't think anybody's going to remember that from 10 years from now, but you might remember that I squared is -1. You might remember that. And if you did, then you can use your rules of exponents to build up to 5i to the 37th. And I think 18 of them gets me close to 36. I think I need one more. And it's very important that you consider what -1 18 times is. That's highly important to your moving up the ladder in this discipline. Sign changes. We're moving into that after midterm in a big way. An even number of negative signs means it's +1. And that was even. So it changes it to +1. So your answer was 5i, not -5i. Binomial squaring. At this stage, you should not have to do 6 minus 2i times 6 minus 2i. You're missing the essence of the course if you're still having to do that. Your answer comes from squaring the first term, squaring the last term. 4i squared. When you square something, you always get a positive. And then doubling the middle term, -12 becomes -24i. Yes, there's more work to be done. 36 minus 24i minus 4. I saw a lot of people leave their answer like that. But I think 36 minus 4, if you go into the store and you want 32 ounces of some liquid in a container, you don't ask the clerk, can you give me where I can go find the 32 minus 4 ounces of milk? No, I think you say 32 minus 24i. That's what we're after. All right. Binomial square, same thing. I'm going to square the first term. That's a 4. That's an a to the 18th. That's a b to the 6th. I'm going to double that product. That product is -3 times 2. Let's let A9B3 equal the number n. Then I would have -6n doubled is -12n. But my n's are A9B3. So I have -6 doubled -12 A9B3. Squaring the last term, always positive. Okay. And I'm hoping that's a 20-second question, just the amount of time it takes to write it on the answer key. We're hoping that you can see 3 times the square root of 25 times 2 minus 2 times the square root of 16 times 2. That's the goal. That's the goal, be able to see that and have it written this way. And then taking it a step further, 15 root 2 minus 8 root 2. Let's let x equal root 2. We have a problem very similar to 15x minus 8x. I hope you would say 7x. And if you see that, then I hope you say 7 root 2 the next time. All right. That takes care of that one. In grade school, hoping somewhere along the line, somebody taught you that fractions are equal if their cross products are equal. And they are. Those fractions are equal because their cross products are equal. Well, I have a fraction equaling a fraction. What has to be true? Their cross products have to be equal. I think we're right back where we were 5 minutes ago. I think we want to subtract, well, moving this to that side means we have an addition. There's no reason you can't divide by 3 here and make it simpler, x squared plus 8x equals 0. And given what we talked about a minute ago, I'm hoping you maybe had factoring come to mind and could see that one of my answers is 0, which I'm not seeing on the answer key often. And I'm hoping I do here pretty soon. Okay, because that's an Algebra 1 problem, pretty early Algebra 1 problem. And we got to fill in gaps still. We're making some good progress in the e to the x, ln of x, sine function, right? But we still got to pick up where COVID and zooming left off. Okay, 5-second question. What are the roots? 5 plus or minus the square root of 7 over 2i. Right, let's put this in more prominent position. 5, 7. A equals 2, which I'm writing because it's cup shape up. That dictates cup shape up. And we're trying to find out when we hit y equals 0. Well, I hope that explains why you have to have I there. There aren't any real roots. In order for there to be real roots, I got to flip it over. Okay, and what happens when you square I? You get a minus sign. And if I put a minus sign up here, I'm flipping it over from 5, 7. I could have put this in graphing form. 2x minus 5 squared plus 7 equals 0. I spent a whole 40 minutes lecturing on how to solve these equations. What's the first thing you do? You subtract 7. What's the second thing you do? Divide by positive 2. That takes care of that. That takes care of that. What's the third thing? Plus minus square root, which means the minus sign goes out as an I. And what's the last thing you do? Subtraction of 5 becomes addition of 5. I think you can see that. Everything's right there. Takes a little effort. Takes a little effort to look at it, but then the 5-second question, you move on and you get one of those, actually 2 of those. Any picture is worth 2 points in my estimation. That's a 2-point question, 5 seconds. Got to think about it. Okay, so I planted this problem to really see if people could factor a squared minus b squared, which is a plus b, a minus b, classic Algebra 1 problem, right? But I hid it. I hid this. Most people wrote 4a squared minus b squared. So 4a squared plus b squared times 4a squared minus b squared. What I was interested in seeing was who spotted that. If you have working knowledge, that means when you see something like that, you go, oh, that's a difference of 2 squares. Final answer, 4a squared plus b squared times 2a plus b times 2a minus b. Open to see that. If I throw it your way again. All right, so that was that problem. 26. Well, 4 goes into everything, so I'm just going to simplify right here. X squared plus 6x. And I'll bring this 56 to the other side. 4 times 14. So minus 14 equals 0. Classic Algebra 1. X times x. I need 2 numbers that multiply out to 14. 1 and 14, 2 and 7. I'm not seeing it. So therefore, what do? Well, no longer classic Algebra 1. Now it's completing the square. So that's x plus 3 squared minus 9 minus 14 equals 0. That's what the brain has to do. You look to factoring. If you can't factor it, what's the next step? What's the next thing I can try? Quadratics have about 4 or 5 different ways of solving. Right? And you need to know each and every one so that you can pick the easiest way to solve the problem. So what do we have here? We have minus 23 on this side, becomes positive 23 on that. We've got squaring becomes plus minus square rooting on this side. And we got addition of 3 becomes subtraction of 3. And unless I'm making a careless error, which I could be, I got a checker. That's your answer. Answers. Yes, x squared. 2 answers. All right, so a little more challenging factoring problem here. Okay, but I'm trying to get to 19. Whatever I multiply by 3, I hope gets me there. Well, the number that comes to my mind is 5. 5 times 3a is 15a. But I want minus 19, so why don't I make that a minus? Wouldn't it be nice if I could get minus 4a out of this? Oh, there it is. And a minus times a minus is a positive. That's a good thing to know. That's a good thing to remember as you're trying to learn to get better factoring skills. That if I have a positive at the end and a negative in the middle, it's got to be a minus minus. There are clues to getting better. That was one. All right, so we're really doing cross products here when you add subtract fractions. We're really doing cross products. So we're doing 2z plus 4. And now I'm doing z minus 1 times z plus 1, z squared minus 1. I definitely see the conjugate coming out of that. And then I have really z plus 1 times z plus 2. And I'll leave it like that because you never know what might cancel. But I see a minus z squared. That takes care of that. I see plus 2z. That takes care of that. And I see 4 minus a minus 1, which is 5. I don't see a factoring problem here. 1 times 5 and 1 and 5 don't get me 2. So therefore, I can either leave it like that or I can multiply it out to be z squared plus 3z plus 2. I suggest you multiply it out for a little practice. All right, distance. A lot of people come in, I've had one student, what's the distance formula? No need for that. 5, 7 is a place on the curve. 5, 7 is a place on the curve. 8, 12. 8, 12 is a place on the curve. 8, 12 is a place on the curve. I'm seeing a right triangle. That's what I'm seeing. And I'm seeing 5 to 8, 3 units, and I'm seeing 7 to 12, 5 vertical change, and I'm trying to find that distance. Well, I got news for you. Have this in your mind's eye. I think these add up to that. So therefore, our distance here is the square root of 34. And that takes care of that. All right, we're getting there. Getting there, wound up. Got all kinds of sunlight, which means you might not be able to see the board when it comes out. All right, everybody should be at x minus 11 at this stage to get the first 2 terms. Automatic. All right, we need to build this. We're talking about a quadratic. Minus 5 times minus 11 is 55. How do you get from 55 to 3? You go down 52 units. X minus 5. How do you check it? You plug 5 in. And 5 will get you minus 52 on this side, especially if I put the minus 52 on the outside. 5 gets you minus 52. If this is the same calculation, that a 5 has to get us minus 52, I'll do it very quickly. 25 minus 80 plus 3 is minus 88 plus 28. Did I make a mistake? Maybe I did. Minus 52, 5 times 16, minus 80. Oh, I wrote 88. Okay, that was bad on my part. Okay, said the right thing, wrote the wrong thing. All right, so minus 80 plus 28 is the opposite of 80 minus 28. 80 minus 20 is 60. Take another 8 away. I think we're okay to move on. Conjugate of 2 plus 3i is 2 minus 3i. The shortcut is to square the numbers 4 and 9, 13. You go ahead and do that out. You'll see you get 13. We'll get the practice we need by multiplying by 2 plus 3i. So we'll get the practice we need. If you have trouble getting that, you'll get more practice here right now. 4 times 2 is 8. 4 times 3i is 12i. Minus 2i times 2 is minus 4i. And minus 2 times 3 is minus 6i squared. Okay, so we got a little work to do here. We've got 8. 12 minus 4 is 8i. And minus 6i squared is actually positive 6. Because minus 6 is getting multiplied by negative 1. I'm seeing 8 and 6, 14 plus 8i over 13. That's what I'm seeing for that problem. Now here's a nice little problem that puts together 4 or 5 concepts. This is the exponent you put on top of x to get what's inside. I think it's a quadratic. I'm going to set it to 0. I'm going to hope I can factor. Looks like I can. In class, I've been saying the base of these logarithms, the base has to be positive. Well, I'm not getting a positive answer out of that parentheses, but I'm getting one here. Let's go back and see if it's true. Let's let x equal 3. What's the exponent you put on top of a 3 to get 9? Oh, it's 2. So that's where you actually had to work with several things, put several things together. And I think you'll see more of those coming your way. So it really tells me if you're processing when somebody isn't giving you a problem like it's a test, then it really gets easy when you start solving 2x minus 6 equals 7. Let's change that to minus 3x plus 5 equals 8. And let's do 10 or 20 of those. Well, great. But the long-term memory, learning that way, doesn't exist. If it did, you would have come into the class knowing how to write the equation of a line. Well, I probably shouldn't even post this, but I'm gonna. Cube roots. Well, you need to know 8, 27, 64, 125. Got to know those cube roots. And I'm seeing one of them immersed. One of them embedded in 250. I think it's 125 times 2. Yes. So I could have looked at the cube root of 125 times 2. X to the 9th is, I think it's x cubed 3 times. And y to the 1. And I see z to the 7th is z to the 2 3 times z. That's another way to look at this. So I'm looking at the square root of 125 is 5. Done that one. Cube root, excuse me. Cube root of 125 is 5. Cube root of x cubed cubed is x cubed. Y is going to stay alone. The cube root of z squared cubed is z squared. I still have some stuff inside the cube root that weren't so user-friendly, like 2, y, and z. That's that answer. So it looks like you can divide the number 3 into the exponents. This was x to the 6th, I believe. I forget what the x to the 9th. That was x to the 9th. Well, how many times does 3 go into 9? 3 times. How many times does 3 go into z to the 7? Twice, with 1 remainder. And you got to know those numbers. And then you can do these problems. All right, I'm on a roll. That takes care of that one. A bunch of factoring here. That's what you do with fractions. You reduce them through factoring. So I'm going to factor the denominator. And if I factor the denominator, lo and behold, I see an x plus 5 times x plus 8. That's this one. And when you divide, you multiply by the reciprocal. Not a whole lot of cancellation here. I can certainly see that becomes the number 1. And 1 times x plus 9 is x plus 9. And therefore, on the denominator, I still have 4x times x plus 8. So there wasn't much cancellation there, but there was some. Okay, so there's a graphical problem here, which is -5 in that direction. The y-axis is over here. I'm at 1, going up at 1 to 1. Looks like I only have one answer here, whereas I might get 2 when I do the mechanics. The mechanics are squaring both sides. I'm not having trouble with this. When you square this, if you don't have the middle term, it's a major error. All right, we're squaring. We're squaring. All right, square the first term. Square the last term, plus 1, and double that product. All right, so now we're here. We set it to 0. X squared minus 3x. Oh, I hope you can see this. The sun is hitting places. Minus 4. Oh, that's beautiful. I like that because I can see 4 and 1 real quick. I can see 4 and I can see 1, and we want negative, so that's minus, that's positive. Okay, so I don't want that answer. That's a fictitious answer. That's -1 there. It's fictitious. But x equals 4 solves the problem. Let's check it. 4 plus 5, 9. Square root of 9, 3. 4 minus 1, 3. 4 seems to work. And it looks like it's positioned in the right place if I drew a better graph. Right. Well, we get answers like this from completing the square. Let's go figure out what square we completed. Let's move the 4 to the other side. Plus minus 6i. Let's square this. X squared plus 8x plus 16. Maybe you got past that doubling and maybe you squared that properly in your mind's eye. This one here is 36i squared, which I think, if I'm not mistaken, is minus 36. So I got to add 36 to this. Then I get x squared plus 8x, 30 and 4, 10 and 30 is 40, 6 and 6 is 12. I think I'm getting 52. And I hope if you were going to solve that, you wouldn't go to the quadratic formula. I would hope you would say, hey, let's complete the square. Let's go x plus 4 squared minus 16 plus 52 equals 0. Let's move that to the other side. Oh, that's positive 36. That's negative 36, excuse me. And that gives me x plus 4 squared. Let's take the square root. X plus 4 equals the square root plus minus 36i. I think when I move the positive 4 over, I get negative 4 plus minus 6i. Oh, yes. If we can go from A to B in math, we generally study going from B to A. We just did. All right, so I got rid of 48 because it was a redundant problem. And I obviously creating 2 tests, 2 answer keys, doing the videos, takes a lot of work. So there's always a little snafu, and I ran into one right there. But let's unsnafu this one. So y equals 3, exponential. I'll start there, and I'll ask, how do I get from that y to that y? Displacement. I got to add 17. Next time, I'm not going to go from 3 to 20. I'm going to go from 3 to 35, and that's not 17. 3 to 35 is 32. So I have an exponential function whose differentials are a little bit more than doubling. T minus or x minus 1999, that's a year. And how many years elapsed? 23. So the mechanics of that aren't hard. Not hard. The mechanics aren't hard. We'll keep talking concept for the rest of the year. All right. So what have we finally landed on for a method of solving? Oh boy, that's a big time problem over here. I'll have to rewrite those problems. Well, spent a whole 40 minutes lecturing on this. Subtract 9 minus 32. Dividing by minus 4, positive 8. What undoes absolute value? Plus minus 8. And then we subtraction of 8 equals plus minus 8 plus 8. And I see answers of 0 and 16. Okay. So now we want to write the pieces. All right, so let's do the pieces of what I just erased. minus 4, x minus 8, was that right? Minus, oh geez, I have to go backwards here. Why did I do that? Can't believe I did that. That's how bad my memory is. Where's the test? I don't see the test. I don't see the computer. The sunlight's too much. Okay, nope, that's a recording. I can't do that. Oh, this is a fun moment. Okay, so I guess I got to go backwards here. So plus minus 8, 8. So positive 8 right there. I added 8, so it was minus 8. Minus 4, x minus 8. And I got to get to 23. So what the heck did I add here? 23, 16. Oh boy, this is terrible on my part. Anyway, honestly, when I get to this stage of a video, I think my brain is shutting down. It was a minus, so it was one of these. All right, and whatever it was, I'm going up at 4 on this side. I'm going down on 4 on that side. And I forgot what the vertex was. So it was positive 4 up here. No, it was positive 8. That much I remember. So this is going to be on the left side. I'm not doing this again. I don't have time. It's 4 times x minus 8 plus whatever the constant was. And that happens when I'm less than 8. For x values less than 8. Yasser, help me out here and give me the corrections later, huh? So then I've got negative 4. This is going down at 4. X minus 8. For x's that are greater than or equal to 8. So that's the piecewise. And I think I asked, when is it less than negative 23? So here's negative 23 somewhere down here. Less than is all of this. Right? And that's these x values. So I need that one, which we said was 0 on the left and 16 on the right. So once I get past 16, I'm lower than minus 23. So I think I had greater than, oh no, it's less than. So I did want lower. Okay, so I want lower than 23. So I'll take that away. Just the opposite of what I just said. All right, it's negative infinity to 0 and 16 to infinity. And the way that's written is negative infinity to 0. And it didn't say or equal to, so it's a parentheses union 16 to infinity. I'll take more time with that in class. All right, sorry for the snafu, but that's where my brain is at the age of 71 with a lot of concussions. So that's where I'm at. Subtract 5. Divide by 3. Lectured on this 2 days ago. Inverse of E, ln. Subtraction of 4, addition of 4. That's all it was. We're going to learn what that is as a decimal equivalent. It's not hard to do. Negative 0.4. I must have done something in my head. All right, we're going to practice that. But that's just the mechanics of getting a correct answer. That's effort on your part. All right, the conceptualization is the brain's got to process things, got to think about things, got to keep talking about them until the lights go on. And I think I graphed this with a student in class who came to Math Help. We graphed y equals 3e to the x minus 4 plus 5. I'm going to change this to 7. I'm going to do a new problem because I don't like the same number appearing anywhere. And I said, okay, you got to have shape. Student was happy with shape. Wasn't hard for the student. Done doing the work. And then the question was, can we do e to the 0, which we know is 1, and e to the 1.1, which we're saying is close to 3. And he said, well, yeah, 4. If I put a 4 in, I get e to the 0, which is 1, and 1 times 7 plus 5 takes me to 12. Then I said, can you solve x minus 4 equals 1.1? He said, oh yeah, 5.1. And I said, well, up here, you got 5.1, and you just created the number 3. Times 7 is 21 plus 5 is 26. We spent 5 minutes on it. And he went, well, that's easy. Said that, is it? No, he actually said, is it that easy? And I said, yes. And it is that easy. Once you do anything enough times, it's that easy. Tying your shoes now is easy. It was not easy when you were 4 years old and you were first learning. How did you get to tie your shoes easily now? I think repetition. I think repetition has come into play. Okay, so how are you going to get good at graphing that? You got to get some reps. And if you're not getting the reps, hey, you're stuck. I got stuck yesterday in the snow. Yeah, I didn't get enough revolutions. I got too many revolutions on my tires. They just spun out in the snow. Took me a long time to dig out, but I got here. All right, started this the first week of class. 16 to the what equals 1/8. All right, we started these problems so we could get to the rules of logarithms. So that's 2 to the 4 gets me that equivalent statement. This is 2 to the -3. 4x equals -3/2. So therefore, 4x equals -3, excuse me, because the bases are the same. So x equals -3/4. All right. Now back to what we did. I can't even see myself over there. 125 to the -3/2. Got to be able to do this to get the rules of logs. I'm still trying to get there. So I take the square root. Was it -3/2? I must have missed. I probably wrote that wrong. Probably -2/3. Right? I wasn't trying to fool anybody. I want to make sure people know that's a cube root. So that's 5. And 5 to the -2 is 1/25. That was that answer. Then we have the same question we did 3 minutes ago. 16 to the 5 minus x. You really needed to convert that. And you needed to convert this. Same base. 3x equals 20 minus 4x. I'm going to bring the x's to that side, make it bring the -4x to this side, make it 7x equals 20, and therefore x equals 20/7. Almost done here. So 27, 8 to the 6. Plus 125 m cubed. Now, why wasn't that right next to the factoring of cubics before? Because it's important for you to have 20 minutes elapse between seeing problems. Because then you find out if you're really remembering something. Cube root, 3a squared. Cube root, 5m. Next parentheses, built off of this one. 9a to the 4th. I square that. I square the 5m. There it is. That has now been squared. I take the product. 15. I change the sign. And then I bring in a squared m. And I'm done. A lot of people are getting close, but having trouble with that sign and this one. For whatever reason, that one I don't understand. This one I do. Takes time to learn. 2 log base 3 of x plus 4. What am I asking? The inverse. So the inverse is writing f of x as y equals, changing the x's and the y's. Changing the x's and the y's and then solving for y, which we lectured on 2 days ago. Addition of 4, subtraction of 4. Multiplication by 2, division by 2. Making sure I'm right here. Oh, I knew I did something stupid. It's the end of the video. I always do. So we got rid of the 2. We got rid of the 4. What's the inverse of log base 3? 3 to the exponent, x minus 4/2. That is my new function, f minus 1 of x. How do I check it? Let's go back to f of x. Let's make this an x. Let's go back to that. I'm going to plug in a 9. 2 times 2 is 4, plus 4 is 8. 9 gets me 8. If 8 doesn't get me 9 here, I got a problem. 8 minus 4 is 4. 4 divided by 2 is 2. 3 squared, 9. I'm moving on. All right, last problem. I wish you could see it. Maybe if I block it, maybe I block the sun, I won't have to rewrite it. Let's try that. Oh boy. Come on, yes. Okay, I'll reach from here. Hopefully you can see that. There. All right, this is no different than 2x plus 3y equals 6. It starts here. You make zeros, and you can do a lot of computation. Well, what makes a 0 here? I hope you say 8. What makes a 0 here? I hope you say 5. So that's my x. That's my y. What makes a 1 over here? Because I got to get a 1 out of this. Well, 6 squared makes 1. So therefore, z could have been 14. And that's just one coordinate. You've got 6 coordinates listed on your answer key. Why? Because when I square things, I could have also used a negative number. And if I put 2 in, 2 minus 8 is negative 6 squared, it's 36. Divided by 36 is 1. And I can get that quickly and easily if I understand the concept of working with zeros. And at the beginning of the year, I told you this course is based on zeros and ones. That's a perfect example. Okay, so I'm hoping that moves the needle. Test on Friday. Similar questions. And whatever you probably get right on the first 20 or 30, if you get it right twice, if you had it right on the last test, which is this one we just went over, and you have it right on the next test, we'll probably shorten the load a little bit and start giving you some checks for, we think you own it, we think you've mastered that mechanically. There's no such thing as mastering anything in math conceptually. I don't believe there is. There's always something new to learn. I don't know, that's out on a limb a little bit when you're talking about linear functions. They're not that complicated, but still seeing things, right? I mean, maybe you're seeing ax plus by equals c differently now than you were. Maybe you're seeing that the slope of this is minus a over b in terms of what we've been talking about in class, and maybe you're seeing the perpendicular slope is b over a. That would be nice, because then if I asked you, write the perpendicular to 2/3 x minus, no, that's not the question. If I said 5x plus 7y equals 83, and I wanted the perpendicular, well, I hope maybe you're writing 7/5 times through AB, x minus a plus b. Maybe you're doing that without any work now. Some of you are ready to do that. You've done it enough, you've done it correctly enough, then maybe you take one more hard look at it, and you can shorten the load. If I wanted the parallel to this, then it's minus 5/7 x minus a plus b. I'm not doing any work. And I'll be corrected, hopefully, if I made a mistake, then I'll put the correction somewhere written in the introduction to this video. Right? Like volume is important, doing a lot of problems is important, and as you do, you get smoother pathways in the brain. I've seen it for 45 years, so engage in the process as Professor Flynn states. And we're going to end with Yasser's, stay safe, stay warm. I like it. Bye.